trig. So here's my right triangle. The right angle is indicated by a, you could say a little box or a little square. What do you want to say? A little square. Okay. The longest side in the right triangle is called the hypotenuse. Okay. In a right triangle, we name the sides of a right triangle in relation to one of its acute angles, theta. Have you seen theta before? It's a Greek letter. Ooh, it's exciting. We get a new language. Yes, that's Greek. Theta. How do you spell theta? It's T-H-E-T-A. That's theta. Theta. Okay, the blank side is the side that is adjacent to the angle theta. So that is the adjacent side. No big things here. Okay, can anybody point to the adjacent side? Well, first off, let's label the hypotenuse. The hypotenuse, of course, is opposite that right angle, right? So this is called the hypotenuse. Yes, we know this from Pythagorean theorem, right? Grade 8 and grade 9. Okay, so let's go back to what the adjacent side is. The adjacent side is the side that's adjacent, right next to theta. So would it be that side or this side? Right here, yeah, that's adjacent. Okay, yeah, you did have a 50-50 guess. However, the definition of adjacent is right next to it. Here's my theta. Do you see? Do you see? That's right next to it, right next door. Do you see that? Okay, and then, of course, the opposite side is the side that's opposite. So do you see which one's opposite theta? Opposite, that would be your opposite side. Okay, so I would do this in order all the time. I'd start with the hypotenuse, then I'd figure out which one, where my theta is, and that's my adjacent, and then opposite is adjacent. Sorry, opposite theta is your opposite side. Okay, so let's just practice now. I'll give you a second to label hypotenuse, adjacent, opposite in each of these two triangles. So did you put hypotenuse here? Did you put opposite here and adjacent here? I'm just abbreviating at this point. So here is my hypotenuse, here is my opposite, and here is my adjacent. Did everybody get that right? Yes? Okay. Half the battle is knowing which side is which here. So now we're going to get introduced to the whole, I don't know, the epitome of trig. Sine, cosine, and tangent. So trigonometry is useful for finding a missing side or an angle in a triangle. The special function sine. I always say, because on your calculator it's just S-I-N, don't call it sin. It's sine. Same with, on your calculator it's abbreviated as cos. You shouldn't call it cos, it's cosine. Like, call it by the proper name, right? And same with tan. It's on your calculator as tan. It's really tangent, okay? So, I don't know where people keep on coming up with the sin, I guess, but it's a sin to call sine sin. That's what I say. Okay, so what do they stand for? They stand for the ratio of sides. So sine theta is equal to opposite over hypotenuse. So if I take the opposite side and I divide by the hypotenuse, I'm going to get what sine theta is equal to. And from there I can actually solve what the angle is. Cosine is adjacent over hypotenuse and tan is opposite over hypotenuse. So how are you going to memorize this? You have to memorize this. And if you've ever done trig before, there is, it sounds like, I don't know, like a Chinese or Japanese word, sakatoa. So what does it mean? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So SOHCAHTOA. I know when I was in high school, my high school teacher had this crazy story and said, two cats sat on an orange and held hands, and then he drew an orange with a cat on it, and two cats holding hands or whatever. Obviously, I'm not an artist, but so how does this work? Tan is opposite over hypotenuse. Do you see? Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. I like SOHCAHTOA better because you can say it in your mind and you know automatically. So opposite over hypotenuse. You know what I mean? It just comes natural. Ka, adjacent over hypotenuse, right? So now we're going to list the ratio here. So the first thing I would do is label the size. Don't write the whole thing out. Let's just use A, H, and O now. Okay, so does everybody see 5 is my H? Now, we have a dilemma now. How do I know which one is my adjacent and which one is my opposite? Well, it depends on which angle I'm talking about. Do you see here, when I'm talking about sine A, that would be right here, which means then this would be my opposite, this would be my adjacent. When I'm talking about sine B, that means this is now my theta, and this is my opposite, and this is my adjacent. So you may not want to label it on paper if you're asking multiple things. So who can tell me what sine A is equal to? Remember, sine is opposite over hypotenuse. So if we look at A, which one is opposite to A? 4, and which one's the hypotenuse? 5. So that means this is equal to 4 over 5. See how I'm doing this? Okay. Cosine of A. Again, here's A. What's cos equal to? Ka, right? Adjacent over hypotenuse. So adjacent is which number? 3 over hypotenuse 5. So do you see how I'm getting this? Tan. Tan is TOA. So it's opposite over adjacent. So here's my A. My opposite is 4. My adjacent is 3. So 4 over 3. Okay, I'm going to give you a second to find sine B, cos B, and tan B. Okay, Kaylin, what's sine of B? Nope. 3 over 5, thank you. Remember, it's over the hypotenuse. The hypotenuse is still 5. Eric, cos of B. Yep, 4 over 5, very good. Okay, and Melissa, tan of B. No, can you wait, Jolene? No, it's opposite over adjacent. 3 over 4, very good, 3 over 4. Okay, we're having troubles here already. Let's try the next one. Okay, I'll give you a moment to see if you can find sine of A. Now, the problem here is we're missing a side length. So what would we have to do first here? I'm sorry? Yeah, we need to do Pythagorean theorem. So figure it out. What do you get? I think this one works out as a whole number. Okay, you should get 25 for this when you put it into Pythagorean theorem, right? Okay, so now I want you to take the time and find sine of A, sine of B, cos of A, cos of B, tan of A, tan of B. Okay? Okay, so I'll just kind of spew out the answers here. You can check it. So this would be 24 over 25. Tell me if I'm wrong, of course. So this is 7 over 25. This is 24 over 7. Did we get all that? Okay, and then B would be 7 over 25, 24 over 25, and 7 over 24. Are we all good? Okay, good. And then, of course, when I did Pythagorean theorem, this is another triple. This is a 12 here. So again, any of these, if you double or triple them, they're all triples. Like I said, so from now on, if you see a 3, 4, 5, 5, 12, 13, a 7, 24, 25, there's a 9, 40, 41, There's like a whole bunch that you'll see over and over again that if you kind of have it in your back pocket like a times table kind of thing, it does save time. Because you're not really getting any marks for figuring out the 12 there. It's just you need to know how to get it, right? So, all right, sine A. So that would be 12 over 13. That would be 5 over 13. That would be 12 over 5. Is that good for everybody? Okay, going to the next one. That would be 5 over 13. That would be 12 over 13, and then 5 over 12. Are we good? Are we checking our work here? This work? Because you don't want to have anything wrong there. Okay.